want to graph this absolute value of 2x plus 4. And there's several ways we can handle graphing an absolute value function. The first thing that you can do, if the entire function is an absolute value, and that's what this is, we got absolute value on an entire function, well, you can just graph that inside function. So I'm going to graph 2x plus 4. That's the first thing I'm going to graph. 2x plus 4 is a line that has a y-intercept of 4 and a slope of 2. So it's going to go through these points like this, over 1, up 2, back 1, down 2, back 1, down 2, back 1, down 2. Okay, follow the pattern. There you go. You can see what's going on here. There we go. And it's going to make a line. You can see it makes a line. I'm going to do my best to draw it here. And there you go. It's only a little bit squiggly. Okay. So that's what 2x plus 4 looks like. But we don't want 2x plus 4. We want the absolute value of 2x plus 4. So what the absolute value does is it changes all the y values that are negative to become positive. So a y value that's negative is just below the x-axis. So instead of this thing giving us back, it's like right here, a negative 3, it should give us back negative 2. But the absolute value is going to force that to be positive 2. And negative 4, it gives us back negative 4. But the absolute value forces it to be positive 4. Yeah, and you can see, well, when it's 0, it's just going to be 0. When x is negative 2, you get 0, absolute value of 0 is 0. If you plug in, for instance, x equals 0, you get 2 times 0 plus 4. Well, that's just 4, and the absolute value doesn't do anything. So that part of the graph stays the same. So all these points up here are going to be the same. They're not changing because the y values are positive. All the points back here are becoming positive y values instead of negative. So instead of negative 6 here, it's going to be positive 6. Okay? And instead of the slope on this side being over 1 down 2, it's going to be over 1 up 2 because we're flipping it over the axis. So really, f of x makes this v like this. So, and this blue line's not even here. There you go. Another way you can look at this is you could, what we were doing in the first part of this worksheet is we were rewriting this thing as a piecewise function. So we can rewrite f of x as a piecewise function, and if you do that, you're going to find out that f of x will equal two parts. It's going to equal just 2x plus 4 if what's inside of it is positive. So if 2x plus 4 is positive, that's greater than 0 or equal to 0, then the absolute value of 2x plus 4 will just be 2x plus 4. Well, this is going to happen when x is greater than or equal to negative 2. So this is x greater than or equal to negative 2. And it's going to equal the opposite of 2x plus 4 when x is less than negative 2. And you can see that. Look here. Here's negative 2. To the right of that, where the x values are larger than negative 2, we see the line 2x plus 4. But to the left of it, we see the line negative 2x plus 4. It's going up this way as opposed to down this way. It doesn't equal 2x plus 4 over here. It equals the opposite of it because it flipped it over the y-axis. So if you graph both of these things, you would see that it would look just like this v as well.